Hi, everybody. So I'm Donal McBreen, and I'm a lead developer at 37 Signals. Today, I'm going to talk about active job continuations, which is interruptible and resumable jobs for Rails. So this is coming in Rails 8.1. Right. So I thought I'd start with this question, which is, what's going to happen if we don't worry about job runtimes? And I'm not talking in the kind of optimization sense of this. I mean more just how we structure our jobs. If we're like, this is going to take this long, we'll just write a job that takes that long, and we don't worry about job runtimes. Well, I guess we should look at the reverse, which is what happens if we do worry about those job runtimes, which is we start creating jobs that create other jobs and splitting things up and inventing orchestration frameworks to make all these things work. So that's what happens when we do. And if we don't, well, we're going to end up with jobs that are simple because we haven't done that. The jobs will just do the work that we need to do, but they're going to be brittle because they're potentially brittle. Not all jobs, but if they could take minutes, hours to run, we're going to have a problem, which is our application can get restarted. We might be deploying all kinds of things like that. OK, so this started with Basecamp. And the situation that we had with Basecamp was that actually we'd let jobs run to completion after deployments. We were deploying with Capistrano, and when we deployed, what we would do is we would boot up some new workers, but any workers that were currently running a job, we'd just let them run all the way to completion. And because we were running it on our own hardware, application restarts were very rare. We just had these servers, they just ran and ran and ran and ran. And that meant that this actually worked not too bad. Our jobs were potentially brittle, but in reality, they weren't really that brittle. But it's still not great. You're potentially running old code for way longer than you really should be. Weird things can happen if you have a deployment and then another deployment, and they're backward compatible, but then you have a following deployment, and it's not compatible with the one from two before, but it's actually still running. You don't really want things like that. We then had a project that kind of forced our hand here, which was we were moving Basecamp to deploy with Kamal. So it was the last, we'd moved all our other applications from the cloud when we were deploying with Kamal, which is a Docker-based deployment framework we'd built. And Basecamp was the last one to be moved. And because it'd never been in the cloud, it was left to last. But it was also our largest app. It was about 10 years old, and had been running in this way where we weren't concerned about making the jobs that short. Like most jobs ran really, really quickly, but some of them could run quite long. So once we'd moved to Kamal, when we deployed, we were going to be shutting down the workers after 30 seconds. So suddenly all these jobs became a big problem, because what was going to happen was we were going to start killing them. And for a customer, you always have these outlier customers who seem to have like 10, 100 times more data than everyone else. And their jobs, instead of taking seconds, could take minutes, or in some cases, the odd case, an hour. And when a job you only need one job that takes an hour, and the chances are it's running when you're deploying. So we didn't want to be in this situation where we were constantly having jobs being killed and having to run them, go back to the start. So we looked and we were like, OK, what are we going to need here? So when we looked at the stats, there was maybe about 30 jobs that we might need to do something about. And what we wanted was some kind of interrupt and resume mechanism we could use across all of the jobs. So we didn't want to be looking at each thing and what it did and adding custom code to models to make sure we could resume that particular job and then doing the same thing again 30 times. When I was talking earlier about how not worrying about how long your jobs take leads to simpler code. So when we looked at the jobs, we really liked how they looked because it just said, here's what needs to be done. It wasn't all hidden in this orchestration logic that's making it really hard to see what you're actually trying to do. It was just all there. So we wanted to minimize the code changes. We wanted to keep that sort of structure where we could see what was going on, but with a new interrupt and resume mechanism. And then it was going to be active job only, because that's what we used. And by making it active job only, we could upstream it to Rails, and then anyone can use it, whatever job backends they're actually using. So then we had a look. Ooh, didn't like that emoji. We had a look at what the possible shapes were. So the first one was multi-step. So these are kind of the shape, like not worrying about the actual logic of what a particular job is doing, but looking at the actual like shape structure of the code in the job. So the first one was multi-step. So that's do this, do that, do the other. So an example might be an export job where you write some files, you zip them up, and then you upload them somewhere. So that's multi-step. Then we have iterative, so that's where we're just going round and round and round. So in that case, you've got some collection, usually active record collection, and you're just applying the same operation to thousands, tens of thousands of rows, which can take a while. And then thirdly, hybrid, which is a bit of both. You've got multiple steps and some iteration. And normally you find if something's slow, there's probably iteration involved somewhere. That's probably the thing that's made it slow. So it's usually one of these last two things. One thing I just wanted to mention is Shopify have a gem called Job Iteration, which is focused really on this iterative thing. And we did have a look at that, but it would have involved making a lot more changes than we wanted to our jobs. And it didn't really focus on this multi-step thing. But I'm going to, when I get to talking about how interrupts and resumes work, it was basically stolen from that gem. So just to be aware of that. OK, so we're going to go through the steps in the API. How do you take a job and make it a continuable job that can work across application restarts? So the first thing is we're going to include this new concern. So here's a job. We're just the export one I mentioned earlier. It's got 3 steps. We write some files, we zip them up, and then we upload them. And we'll include our concern. So there we go. So this is going to So this is going to do 2 things. It's going to add a new method called step into our class, and it is going to wrap the perform method in and around perform callback. So we've got this new step method, and now we're going to use that to break our job up. So here's a job, and then it looks like this. So you can see we've taken each of those 3 parts to a job, and we've wrapped each one in this step method. And what the step method does, it takes a name and then a block, and the block contains our code. So here we are. And what happens when we run this is that we're going to run these blocks immediately. So if you imagine you're running this job, and we don't need to do any interrupting. It's all fine. We get enough time to run it. It's just going to go into the first step, run the block. Second step, run the block. Third step, run the block. Run the same code as before we added these steps. And that's how a job normally works in the simple case. So what's important here now, though, is that implicitly there are what we call checkpoints in between these steps. Whenever you have 2 steps in between them, active job continuations is going to add one of these checkpoints. And I thought the easiest way to explain a checkpoint was just to look at the code, and it looks like this. So it's just 3 lines. If queueadapter.stopping, raise this interrupt exception. So queueadapter.stopping is the only thing that a job backend needs to implement in order to be able to integrate with active job continuations. And it's just a method that once your worker has entered kind of shutdown mode, will start returning true. So we can add these checkpoints into our job. We've got these implicit ones between steps. And if at any point before we move to the next step, we see that it's shutting down, we'll just raise this interrupt and jump straight out of our job. So you can see here, we have write files. So we write the files. And we go, are we stopping? And if the answer is yes, we'll just interrupt, and we won't complete the next steps. And that stopping normally will work like, I don't know, if you're running in Docker, you'll do Docker stop. You'll have a timeout. Docker will send a terminate signal to PID1 in the container. That will propagate down to all your workers. And some signal handler in your job backend code will start initiating the shutdown sequence. So that's kind of normally the process you'd have there. OK, so interrupting. What's going to happen there is we're going to raise that interrupt exception, as we said, and then we're going to rescue that. So it's going to be rescued in, earlier I mentioned that we had that around perform callback. So that's wrapping our perform method. So our method's just going to raise this exception, and the callback is going to rescue it. And then after it rescues it, it's going to retry our job via active job. And that's the point that we save our progress at. So our progress is basically the list of steps we've already completed. So active job, when it's retrying a job, as far as the underlying backend is concerned, it's creating a new job. It's like a new job for the backend, but active job has the same ID, as the other job. But because we're creating a new job, that's basically our storage. So we store the information in that new job in the back end. So this is what makes it active job only. But it does mean that that's the point your progress is saved. So it's really important that you have these checkpoints, because nothing gets saved until you hit a checkpoint. And if something else kills your job because it doesn't have a checkpoint, then the progress won't be saved. OK, so we've interrupted our job, and now we're going to resume it. So when we want to resume our job, we've just retried the job, so it's gone back in the queue. A new worker will come along, it'll pick up that job, and because we included our progress in the job, the list of steps we've already run, we're just going to skip those. OK. So I've tried to draw a diagram. Hopefully this helps a little bit. So time is traveling downwards down the slide. We've got worker one running. So it's running an old version of the sort of previous version of our app. It's picked up job number 1, 2, 3. This is the job we saw earlier. It runs this step, write files, and as that's running, we decide to deploy. So 2 things are happening. We're going to be booting a new worker, which is worker 2 over here, and we're going to be signaling worker 1 to tell it should shut down. So when worker 1 completes the write file step, because it's shutting down, we're going to get that interrupt, we're going to get that retry, and our worker's going to exit, and that's the end of worker 1. Then on worker 2, where it's running along, it's booted. At some point, it picks up the job 1, 2, 3, which was retried, skips the first step because it knows we already ran that, and then runs the following 2 steps and finishes the job. So we have each of our steps run just once across 2 job implications across 2 different workers. OK. So the thing is, we still have a problem here, which is, as I said before, we really want to hit those checkpoints so we can save our progress. But when we're deploying, we're going to have some kind of grace period. What normally happens is you signal the back end saying you need to start shutting down. The back end will probably have some code in it saying, I'm going to have to shut down within 30 seconds or so. And if the worker itself, if the job is still running after that amount of time, it's going to force it to terminate in some unpleasant way. And if we exceed the grace period if we have a step that exceeds the grace period, we're going to be terminated. So what we need to do is add some manual checkpoints in our steps. OK, so here's our progress so far. We've included our new concern. We've broken our step up. And now our third thing we need to do is manually checkpoint those slow steps. OK, so we've got a new job here. We're just destroying a bunch of records. Someone's canceled their account. We've got the account. We're going to go through the records in batches and destroy those. So if we apply our first 2 steps, we're going to end up with a job that looks like this. And this is basically totally useless, because we've got 1 step. Our checkpoints are in between our steps, so we've got no in-between steps in this. So when you run this, even though we've got a step, it's just going to go into the iteration and just go round and round and round, destroying records. And if it'll just keep trying to go to the end, and if it doesn't reach the end, we're just going to have to kill it like we did before. So if we want to add some manual checkpoints, we need to do these 2 things. So the first thing is we've added a step argument to the block. So the block can take a single optional argument, and this is a step object. And on that step object, there's a checkpoint method. We can call that method. And if we call it in between each batch, we're adding these manual checkpoints. So if at any point, and then our job looks like this, so if at any point we start shutting down, we'll complete the batch we're on, and then we'll immediately checkpoint. And that allows us, first of all, to save a progress, which is maybe not that interesting in this particular example, but is more interesting in more complicated examples. But the other good thing is that we're going to exit really quickly. So this can help with making your deployments faster. If you can basically have your jobs preemptively stop themselves rather than trying to run down the clock. Even if you have a job that is fine to resume, it's idempotent, it's able to kind of carry on from where it was before, you still kind of have to wait for it to give up. But this gives the job the chance to say, I'm going to give up as soon as possible. So when we resume, when we've interrupted like this with one of these manual checkpoints from within a step, when we resume, we're going to repeat that interrupted step. And the reason we're going to repeat it is because we didn't finish it. So there may be more work to be done. So in some cases, that could mean that we have to repeat a lot of work. Now, you want all your jobs to be idempotent. It should be OK to repeat a lot of work, but idempotent doesn't necessarily mean quick. You might need to go through and just do all the same calculations again and get the same results. Or you may need to go through all these records and go, oh, I've already done the work here, and it can still be slow. So we have one last thing we need, which is a way in those kind of iterations to continue on from where we were before. And the way we do that is we track iterations with a cursor. OK, so this cursor is accessed via the step.cursor method. So this step is that step object we saw before that you can pass into your block. And it defaults to nil. And if you want to write the cursor, you just call setBang. So the set is setting the cursor value, and the bang means it's also a checkpoint. So whenever you write to the cursor, it automatically generates a checkpoint. So here's a little bit of code kind of showing the methods we've seen on the step object so far. It's not exactly like this, but so we've got that checkpoint method that we saw where it checks if we're stopping and raises the interrupt exception. The cursor is just an attribute. And then this set method is we're going to set the value of the cursor and then call that checkpoint. So whenever we set the cursor, we may also interrupt at that point. And the important thing with the cursor, what makes them useful, is we're going to restore the value of the cursor when the job is resumed. So if we call that setBang method, get interrupted, when we resume, we're going to come back with the restored cursor value. But we need to use that. So we're going to have to take our iteration code and rewrite it to use that cursor. OK, so another job. This one, we have an account, and we're going to notify all the users. I don't know, they need a daily update or something, so it's time for everyone's daily update. So we go to the account, we've got a bunch of users, and we're going through all of those. We call notify. We've already added our manual checkpoints to this, so after each user, we call step.checkpoint. So this is great. If at any point we're shutting down, we'll hit a checkpoint, we'll interrupt the job, we'll go through that nice, quick interrupt and resume logic, but when we resume, we're going to go back to the first user again. And even if we've made, which we should, user.notify idempotent so that it won't send 2 notifications, we're still going to have to go through them all, and it might be just as slow to not send a notification as it was to send one. So what we really want to do is carry on from where we left before. So we've got this cursor, and what we're going to do, these are the 2 lines we're going to change, and we're going to do this. So what we're doing here, firstly, is we're passing the cursor in as a start value for our find each. And as I said before, the default value for a cursor is nil. So when we first run this, the first time you run a job, we'll just start from the very first user, which is what you want. Then after each user, we're going to set the cursor. And the value we set it to is the user ID plus 1, because that's a value we'd want to feed back into start if we had to continue on from here. So we'll go round and round and round, iteration around, notifying users, and then we deploy. And what happens is we hit that set, user ID plus 1, and at that point, we'll save that cursor value, job resumes, and that user ID passed into start, and we carry on from where we were before. So there we go. just one bit of syntactic sugar. If you're not a fan of this +1, you can also do advance from user ID, and that will advance our cursor for it. It actually will call the succ method, S-U-C-C, I assume that's how you're supposed to pronounce it, on whatever the cursor is. So, okay. So that's our job now. So now we've got a resumable job. This is kind of the iteration job shape. It's a single step, but we can go through notifying our users happily. And so here's a recap of everything we need to do. Include the module, break up your job with some steps, add manual checkpoints, use checkpoint if you don't need a cursor, use set or advance if you do need a cursor, and then use that cursor in your code to track your iterations. Okay, so there's some pitfalls we need to be aware of. I've kind of alluded to some of these so far, but the first one is that these steps need to be independent. So imagine you've just got a job with 2 steps, step 1 and step 2. And what happens is you're running along, you run step 1, and then you interrupt, and then you resume, and in a second job you run step 2. Well, you don't want to have any code in step 1 that like sets some variable that step 2 needs. So those steps need to be independent. And sort of related to this is the thing I've mentioned before. You want to checkpoint more often than the grace period. Otherwise, you're just giving yourself up to the the gods of random signals, arriving in the middle of your job somewhere and hope everything comes back okay. You probably have to manually retry your jobs. You'll lose your progress because progress is only saved when you checkpoint. You have to give up control yourself for that to be saved. So you don't want that. There is an option which can help with both of these. So you can mark a step as isolated, and if you mark a step as isolated, it will always run in a separate invocation. So as soon as you hit that step, if you've already run something, it'll just interrupt and resume from wherever, and it'll force the steps to run independently. And that can be quite good if you can afford the extra jobs and you're happy with that. That might be a better way to run, because then the steps will always be run independently. And if you've got a slow step that it's just doing some long operation that you can't avoid, you can checkpoint. So you can't checkpoint more often than the grace period. At least you can save your progress before you start that step. And then finally, we don't want any checkpoints inside database transactions, because at the point of the checkpoint, especially if you've got a cursor that you're saving, you're saying, I got this far. And if you're in a database transaction and raise an exception, it's just going to roll back what you did. So you didn't really get that far, and you're going to assume you did something and you didn't. Actually, in Rails, what it will do is there's a specific exception it will raise if you attempt to do this. So it'll just check, are there open database transactions? If so, it'll blow up when you try and checkpoint. So in the example, before, our cursor was a user ID, so we were using an integer. But it doesn't have to be an integer. It can be anything as long as we can serialize it, because we're going to serialize it back into a job when we retry it. So any of the common Ruby classes that can already be serialized, like array or string, you could use that. If you can create your own custom objects if you build a serializer. I've tried to think of a reason to do that, and I haven't come up with one, but I'm sure there is. So that's something you can do. And I'm just going to show one example of doing this, which is if you're doing nested iterations. So we have just the kind of step logic here. So we've got our notify. We've got a step that notifies all users. So it's like the one we saw before, except we're going to go through all the accounts, and then in turn, we're going to notify the users for those accounts. So we've got these 2 levels here, account and then user. So we're going to use an array. Done. OK, right. We'll go through that bit by bit. So the first thing, our cursor defaults to nil, but you can pass a start value in on your step and change the default. So for this, we're going to use an array containing 2 nils as our default. And we're going to use the first item in our array as our kind of count ID, and the second item as our user ID. And then as we step through account.findEach and account.users.findEach, we pass that first cursor value and the second cursor value in. And the first time we run this, they're both nil, so we start with the first account, and at the first account, we start with the first user. So we're doing what we'd expect. Then we notify the users. Then after each user, what we're going to do is we're going to set the cursor, and we're going to set it to the account that we're currently on, and then the user we just notified +1. And what this means is we go round and round and round, but if we're ever interrupted, when we resume, our cursor is going to be set to this value. We're going to go back here to the account that we were already on, the same account, and then go to the next user. And then a similar thing, when we finish an account, we just mark, OK, now we're on the next account, and just set the user ID to 0, so that when we resume, we'll go to the following account and start on the first user. And if you don't like the look of all these nils, you could put a 0 in instead, and it would work just as well. OK, so that's nested iterations. Another thing that you could do is say you've got like some third-party API, and it's got you're importing records, and it's paginated, and they give you like some opaque key for the next page. You could use the cursor to like store that key, so you could just have a string cursor in that case. So because you need to change your job, you actually probably want to test that those changes work OK. So there's some helpers you can use if you've done that. So if you include active job continuation test helpers, this is going to give 2 new methods. So I'll just got one of them on this slide. So there's interrupt job during step. There's also interrupt job after step. And how this one works is you give it the name of the class, the name of the step, and a value for the cursor. And once those, once you hit those criteria inside the block, it will simulate a shutdown. So you need to be using the test adapter for this to work, but the test adapter is going to start saying, yes, I'm stopping once it sees that those values are set to that. So you can use that to test what happens if I get interrupted. Do I actually resume from the right place? Does all my data actually get updated correctly? OK, so this has been running on Basecamp for over 6 months, maybe more like 8 months at this stage. We had those 30 different jobs that we sort of thought we'd need. I had a look last week, and depending on the time of day and how much traffic we have, a deployment will see between 10 and 40 jobs get interrupted. So it's kind of regularly exercised on every deployment. Now, it's not that we have like 10 to 40 really slow jobs running at any point in time. It's that once you hit the shutdown sequence, any job that's running that has checkpoints, as soon as it hits the first one, it's going to interrupt itself. So this has the added benefit that potentially your deployments can get quicker because everything will shut down quicker. It's potentially because you're going to be stuck with whatever the slowest thing is. So you have to make everything faster for that to actually work. But still, it's one step on the way. So if you've I think what can happen is that sort of question I asked at the start about what happens if you don't worry about job run times. Well, it seems a bit of a crazy question because I think we internalize the idea that we need to keep our jobs short. And we sort of looking at the work that needs to be done, and we're like, OK, we're going to have to break this up. And everywhere you go, every time there's no particular way to do it, you go, well, I'll have this job, I'll have it check and restart itself sometimes, or I'll have this job create this other job, I'll build my own orchestration framework, I'll build my own workflow thing. You can just get that, and like the same app hits the same problem 6 different times, and it uses 6 different solutions. So you can just end up with this, but kind of slightly messy setup. But what I sort of encourage you to look at is, can we build our jobs as if they are long-running things and just have them explain the entire story of what they need to do, but use potentially plug in active job continuations to allow them to break up and interrupt and resume as they go along. So that's kind of the idea here. OK, so it's coming to Rails 8.1, which I think the beta has maybe just been released or just about to. If you're on Rails Edge, you should have access already. Of the adapters, I think SolidQ and Sidekick have support in them already. If you are using a different job backend, it should be pretty easy to monkey patch that method in if you want to. Sort of trying to get it into delayed job and rescue, but they're not very active at the moment. But for both, it'd be really easy to monkey patch it in if you want to try it, if you're using those, and the same for any other backend. And if you're looking for any docs, at the moment, that's probably the best place. And that was me. Thank you very much.